Hello everyone. Now today's class about op-amp differentiator. An op-amp differentiator is an op-amp circuit that has an output voltage proportional to the instantaneous rate of change of the input voltage. The differentiator gives an output voltage that is proportional to the rate of change or slope of the input voltage. So, to prevent magnifying high frequency noise, series resistance R is included in the circuit. So, our feedback of the op-amp is a resistance. Our applied voltage with the capacitor. So, what does mean when you applied a DC signal, when you applied a DC signal in the input, our output becomes 0. Our output becomes 0. Why? Because the signal is not at all changing with the time. The signal is our DC source, no frequency in our DC source. So our output in the op-amp becomes 0 because the signal is not all changing with the time. Again, when you applying a square wave, when in our input is square wave, in the output will get a spike signal. That means with fast raising time of this input, so we get in output spike type, fasting of timing transition. So what does mean? The differential circuit can be used to find high frequency components of the input signal, or we can use this differential circuit for aging detection purpose. So differentiator op-amp is mostly used for aging detection purpose. So to analyze our op-amp, how to get V out according to the rules of golden rule, virtually grounded, V inverting and V non-inverting, virtually ground. So our inverting becomes 0. So at this time, IC equal to IF. So IC means charging of discharging of this capacitor. So C of dVc over dt equal to, what about IF? That V inverting becomes 0 because virtually grounded with non-inverting. 0 minus of V out over RF. So this means when you simplified the circuit, C of dVc over dt equal to minus V out over RF. So we get from this one Vc minus C of dV in over dt, it becomes equal minus V out over RF. So to find V out, simplified, V out becomes minus of Rf times C d of V in over dt. So simply minus Rf capacitor of d of V in over d of dt. This is our V out in integrator. So the gain of our op-amp depends on the feedback resistor and the capacitor. So when you're applying the capacitor in AC circuits, that depends on the frequencies. That means capacitive reactance XC becomes 1 over 2 pi FC. So the gain of our op-amp, it depends on the frequency of the inputs. So in your PowerPoint, that V out becomes minus of feedback resistor capacitor of the input times d of V source, that is V in over dt. So an amplifier can utilize the relation between charge and currents. So what I said, differential application is mostly purpose used for edge detection purpose. So it differential response to a square wave. The differential is good at detecting edges or transitions, very useful in digital circuits. So mostly applied and differentiator op-amp is in edge detection purposes. But don't forget, don't confuse the differentiator with a differential amplifier. That is a differential is that is an aspirator. So this is about a differentiator. So a differentiator is depend on the frequency, that is directly proportional with the frequency, that is sensitivity to the frequency. So thank you.